So first I want to pretend, and I'm going to do this off to the side. You guys don't have to do this. Let's pretend like we wanted to start tangent the same way that we start like the sine and the cosine, right? I mean, that would be a fairly, like if I didn't know anything about it, that's how I would attempt to build the parent, because that worked for sine and cosine, and it's a trig function too, right? So I'm going to do this off to the side. Again, it's not going to be totally what you guys have to do, or maybe not. Yeah, now I'm way off to the side. Sorry, I moved it like 3 times and just didn't want to go. If I did that, so you guys don't have to write this part down. I'm just trying to demonstrate for you, and then we'll write down the official one in a minute. So with sine and cosine, we did 0, pi over 2, pi, 3 pi over 2, and 2 pi. And then we went around the unit circle and we calculated, we just got the sine if we were doing sine function, cosine if we got the cosine function. So right now we're going to go there and we're going to get the tangent. So if you guys have unit circles and want to look at them to help you, you can do that. At 0, okay, so over here at 0, the points are 1, 0. So what is the tangent at that location? So tangent's the y divided by the x, so we get 0. Okay, at pi over 2, which is up here, the coordinates are 0, 1. What is the tangent at that location? Undefined, okay? It's okay that it's undefined. Like, don't freak out that that can't be put on the graph. It can be put on the graph. You guys had some undefined things that you did mark on graphs in Algebra 2. Does anybody remember how we marked something on the graph that's undefined to say you can't really plug in this x value? An asymptote, right? Through the x, a vertical asymptote saying like this x is off limits. So like this just means our tangent function is going to have some asymptotes in it because there are places that we can't plug in the value. If we go over to pi, that's this location over here, the coordinates there are -1, 0. What would the tangent be? 0, okay. And then 3 pi over 2 is down here. The coordinates are 0, -1. What would the tangent be? Undefined. And then back at 2 pi is the same as 0. We'd get 0. So there's definitely a pattern here, just like there was before. So there's the good news. There is pattern, and it does repeat itself and everything like that. The problem is this enough pattern to determine what's happening in the graph? No, this is like an asymptote, 1 point between the asymptote, another asymptote, 1 point. I need more information about what's happening in between the asymptotes. So with tangent, we can't just use every 90 degrees. We have to get a little more specific. So do you guys remember, I mean, we could go anywhere on the unit circle, but I'm going to try to choose wisely. Do you guys remember where else on the unit circle the tangent worked out relatively simple, even though we had to like divide things out? Good. The things with the rad 2 over 2s because they had the same coordinates in both of those. And so those happened at all the 45 degrees. Okay, so that works well for 2 reasons. Number 1, when I divide rad 2 over 2 divided by rad 2 over 2, the answer is always going to be 1, and then I'll deal with if it's positive or negative. Number 2, using pi over 4s is kind of nice because a fourth is halfway between the halves. So it's just kind of like something in between all of these right here. Okay, so I'm going to try getting a little more specific. Okay, so if I plugged in pi over 4, which is the 45 degrees, which is here, the coordinates there are rad 2 over 2, rad 2 over 2. Okay. When I take this and divide it by this, something divided by itself gives us 1. Okay. I'm going to go to the next pi over 4 after I go to 90, which is over here, 3 pi over 4. Its coordinates are negative rad 2 over 2, rad 2 over 2. Okay. So again, the rad 2 over 2 divided by the rad 2 over 2 is 1, but this time it's a positive divided by a negative. So it's going to end up being -1. Is that okay with everybody? All right, down here at this fourth, that would be 5 pi over 4. Okay. It has a negative rad 2 over 2 and another negative rad 2 over 2. What are you going to get for the tangent at that spot? What are you going to get when you do negative rad 2 over 2 divided by negative rad 2 over 2? 1. Okay, and then lastly over here would be positive rad 2 over 2, negative rad 2 over 2. Okay. And what are we going to get when we divide this negative by that positive? -1, and that's at like 7 pi over 4. Okay, is there a pattern? Are we seeing a consistency like we saw with sine and cosine? When you look at the outcomes, do you see that you go through certain values and then they start repeating themselves in the same order? Yes, so that's a good thing, right? That means it still is going to follow that pattern. Notice for sine and cosine, we had to go all the way from 0 to 2 pi before we could see repeated values, okay? Here's 0, it goes 0, 1, undefined, -1, 0. When it gets back to that 0, does it start repeating itself again? Yes, it does the same values in the exact same order. Then do I have to go all the way from 0 to 2 pi to see what one cycle of the tangent looks like? No, I only have to go how far? From 0 to pi. So that means I only need these values for my parent function. Okay, so we are going to use this portion of the table as our parent function. Okay, is this okay with everybody? So what this means is I want my parent function to be this, only from 0 to pi. But I still want the same number of points. So remember, with the tangent function, every 90 degrees was not specific enough. We had to go every 45 degrees. So I'm using fourths. So 1/4, 2/4, 3/4, and then 4/4. Okay, and we already did the calculations right here. So I'm just going to take these values and put them over there. Okay, so 0, 1, undefined, -1, 0. Yeah, no. Yes. So this is the parent function for the tangent. What does this mean about the characteristics of the tangent? What's the period for the tangent? How long did it take us to get through one cycle before we start repeating itself? Pi, not 2 pi. Okay, so second major difference. First major difference, like, graph gonna have some asymptotes in it. Okay, whatever. Second major difference, we don't have to have a period of 2 pi for these functions. If they are the parent, have a period of pi, okay? Which means their frequency would be 1/pi, and we'll talk about amplitude when we go to graph it, okay? So I'm now gonna go to graph it, and I'm gonna use both the charts we made, because here's the thing. We don't really want the extra points. This is one chart, but I think visually you guys are not gonna necessarily like the way that the first period looks. You're gonna like it continued a little bit. So I'm gonna show you both of those things. So I'm gonna number by pi/4s this time. I mean, which technically is the same as the others because I skipped one on their lines, but okay. So there's the first cycle of points that I'm trying to look at. This is 1 and -1. Make it bigger for you guys, sorry. Just trying to make sure we can still see the points. Okay, so I'm going to plot the points that we have from the parent, okay? So we have at 0, we should be at 0. So I'm going to plot the point 0, 0. At pi/4, I'm supposed to be at 1. So I'm going to plot the point pi/4, 1. And then at pi/2, it says undefined. So what did we say happens when you're saying something on the graph is undefined? Yeah, asymptote. You're literally not allowed to plug in that x, so it breaks apart your graph, and we mark it with like this dashed line saying like, nope, nothing can be plugged in here. This is undefined, not allowed, okay? Then 3 pi/4 is at -1, and pi is back at 0. I'm going to draw a few more points. This is the parent, but until you guys get used to it, I'm going to draw a couple more points in each direction. I'll draw them in a different color so you guys can tell they weren't part of this chart, but I just want you to be able to see what's happening. So if we continued this pattern, right, the points go from 0. When you go over, they go to -1, 1, undefined, -1, 0. So after 0, the next one over should have a point at 1 again. So like this one would have a point here. And then the next one over would be undefined, the asymptote. You guys will probably like this picture a little bit better. That's the reason why I'm putting it in there. Okay, so what does this really look like? here's what it really looks like. Actually, I'm going to go the other way too. So for this one, see how you have the point at 1 and then 0? It would have a point at -1 and then an asymptote. So over here, it would have a point at -1 and then an asymptote. So if you guys remember from Algebra 2, when you get really close to a vertical asymptote, it's not like the graph just like goes and goes like, and just like stops right in front of it. What happens as you get closer and closer to a vertical asymptote, you're only skipping that number, which means you have points for every number around it. And numbers are weird. What is the closest number to this number? I don't know. There's like a little decimal that's right next to it, but I could find another decimal in between those two and another one in between those two. So what happens when you get really close to vertical asymptotes is the graphs curve either upward towards the vertical asymptote or downwards toward the vertical asymptote. They start to look like they're vertical even though they're not technically vertical because they don't just come to a screeching halt. They get all those points, and it's really weird. It's like there's a stopping point, but there's infinitely many points between the place you are and the stopping point. So like the graph never stops, but it never makes it through that wall kind of thing, okay? Something like that. So what's happening here is as we get close to this asymptote, the points are going up. Whereas from that perspective, closer to this one, the points are going down. So what you're going to see in between here is a curve that looks like this. So I'm going to draw the parent part first, the part we graphed in blue. If we just had those points, here's what's happening. This and this, okay? But a lot of people don't like this picture of the tangent function because they want to like finish the curve and get to the next asymptote. If you struggle with that, my advice would be to do exactly what we did with the parent. Do the parent, do the transformation, plot the points, and then follow the pattern a little bit so you can see where the next asymptote is and how it curves. What this is really going to look like when you have a bunch of them on the page is the continuation that we have here. They look like this, okay? So tangent functions have these kind of like infinite curves. They reach infinitely upward and infinitely downward, separated by these asymptotes, okay? Very different from the sine and cosine, okay? The sine and cosine have maximum and minimum values. The tangents don't because you're dividing two things. And when you divide two things, you can get many, many different answers, infinitely many, okay? Is this okay with everybody? So we're going to use this as our parent, but I wanted you to see the extension of the points so you can see like you expect curves between asymptotes overall, even though the parent function is just giving you part of that curve, the asymptote, and part of the next curve, okay? What we're going to do with this is the same thing that we did with the cosine graphs. Before we leave the parent, there's one more characteristic that we want to put on there. So you guys should have this chart. You should have at least what's graphed in blue here. That's officially the parent. I just wanted you guys to see the bigger picture and what it would look like. You should know that the tangent function period is pi, and therefore the frequency is 1 over pi. What is the amplitude of the tangent function? Yeah, so your idea is right, but it doesn't have one technically. And amplitude is like, what is this measurement? And you're like, it doesn't have one, so we just write none. So the amplitude should be a give me if you actually know what's going on. If you're asked to graph a tangent and it says like period and amplitude, you should just immediately write none next to amplitude no matter what's happening to the tangent graph because it always looks like that, and that measurement doesn't exist on that graph, okay? Because that's a measurement from the middle to the top, but a tangent doesn't have a top or a bottom, okay? Is everybody okay with the parent function before we try to go and transform it? Okay, so let's go and do transformations. We're doing one tangent example. All right, we've got some fractions in there for you guys to help those of you that need some practice with that. Oh boy, that's okay. Breathe. So this is the tangent function that we're going to focus on. So as you guys are copying this down, remember that the first thing that we're going to want to do is rewrite this, okay? Who can explain to everybody why we have to rewrite it? Because a few of us still aren't getting it, like we aren't rewriting it. We're just kind of jumping right in and saying like h is pi over 4 and stuff like that. Paige? Good. It helps you with your transformations. You have only studied shifting left and right if it comes from this quantity. Oops, sorry. X minus h. What number is in front of x when I write x minus h? 1. You have only studied how far things move things if there is a 1 in front of the x. Now look at your tangent equation. What number is in front of the x? Negative 1/2. You never studied that, so you don't actually know what that pi over 4 is doing until you rewrite something in that exact format. So we need to separate the negative 1/2 from what's left in this quantity so it looks the way that we've studied it, and then we actually know what it does. So the 1/3 is here. I know the b value is negative 1/2, and then there's no k value. So the question is, what ends up in there when I take this out? So some of you know right away, you're good with fractions, you're good with understanding what it should multiply to get that. If we don't do that, you say, okay, I had a negative pi over 4. Write that down. What did you do to the negative pi over 4? You factored out a negative 1/2. In other words, you want to know what's left if you divide negative 1/2 out of negative pi over 4. So you're dividing out a negative 1/2, which means it's like you're multiplying by negative 2. These leave a 2, and a negative times a negative is a positive. So this would leave me with positive pi over 2. If you're uncertain that you did it correctly, you should be able to check that if you multiplied it back in, it would match the original equation. So negative 1/2 times x would give me negative 1/2 x. Negative 1/2 times positive pi over 2 would give me a negative, which it has. 1 times pi would be pi in the numerator, and 2 times 2 would be 4 in the denominator, so that gives me a little more confidence in what I'm doing. Okay? Is this all right with everybody? Okay. So then table setups. Okay, so first you need your parent function, so if you have to, go back and look. If you don't think that you need to look, then maybe practice like how you know you're going to make that parent function table. So our parent function for the tangent doesn't go to 2 pi, it just goes from 0 to pi, and we couldn't go every 90, we had to go every 45, so those are the pi over 4s. I'm saying this out loud because that's like how I'm remembering it. And you guys have the unit circle, so if you know that you have to go every 45s, but you know the period, you can see that a 45 is pi over 4 on there, and you can get all 5 of those angles. And then you can either memorize or go through and calculate the tangent at those points. So this was 0, 1, undefined, negative 1, 0. Okay. So again, I'm responsible for knowing this, whether that means I flat out have memorized it, I understand how to get it from the unit circle or something else, that's what I'm getting. All right, the transformations. Okay. We'll make the headers for our table and then we'll go and write them verbally in words, okay? So what is going to be happening to x? So we're going to focus inside of the tangent function to understand what's happening to x. Olivia. Subtracted. Is that okay?
Oh, yes.
Yes. Okay, so we're going to have negative 2x minus pi over 2. So where this is coming from, okay, so our b value right here is a negative 1/2. We know a negative just causes the sign to change, so we keep it negative. We've studied that even though a 1/2 is in the equation, the calculations on the graph don't actually get half their size, they actually get double their size. So therefore we've used a 2 here. And we know that x plus pi over 2 actually shifts our graph to the left pi over 2. Okay? Is that okay with everybody? In words, how do we say those transformations? So what is the negative? What are we going to say for that? Reflection. And which axis is it over in this case? The y-axis, right? You're switching x's. If you change x's from positive to negative on the graph, they flip left and right, which is over the y-axis. Okay. How do we describe multiplying by 2 those x distances on the graph? Close but horizontal because it's happening to x. So because it's happening to x, it's horizontal. Because the distances are actually getting times by 2, even though there's a 1/2 in the equation, they're getting stretched. And then the minus pi over 2, like we said, would shift us to the left pi over 2. Okay. I'm going to pause for the horizontal stuff for a minute. So what you should be asking yourself for the horizontal stuff is, are you okay that we rewrote it? Are you okay that these numbers in the equation actually affect the measurements this way on the graph? The numbers in the equation mean one thing, but what we measure on the graph is slightly different. Here's how they affect our measurements on the graph. And then are you okay with the reflection, the stretch, and the shift? Okay? Any questions about any of those things that I just mentioned that came from that horizontal stuff? All right, so what's going to be happening vertically? What's going to be happening to the y distances in this equation? Olivia, but she already told us. So what are you guys literally going to write if this is your equation up here, right here with y? 1/3, okay? All right, so is that a vertical or a horizontal change? Vertical, because it's happening to your vertical distances, your y's, so this is vertical. And when you multiply something by 1/3, so we want to look at what we're actually doing to the points we're plotting, because that's the visual that we're going to see. If you multiply their previous distances by 1/3, are they getting closer to 0 or further away from 0? Closer to 0, which means they are getting compressed, made smaller, okay? Is everybody okay with the setup here? Okay, so in words, those are our transformations, and then here's how we'd set up the table. Okay. All right, so we'll do the y values first. Those are going to be a little bit faster, and then we'll walk through the fractions because people are still struggling with getting through some of those transformations. So I have to take all of these and multiply them by 1/3. So 0 times 1/3 is still 0. 1 times 1/3 is 1/3. You can't do any mathematical operations with something that's undefined, so this is actually a lot easier than you would think. If it's undefined, then it still is undefined, okay, because you can't do anything with it. -1 times 1/3 is -1/3, and 1/3 times 0, again, is 0. And now with each of these other values, I'm going to take them, multiply them by -2, and then subtract negative pi over 2. So 0 is okay. Most people are getting that one right. That times 0 would be 0. 0 minus pi over 2 is negative pi over 2. All right, so for pi over 4, I'm going to take -2, multiply it by pi over 4, okay, and then subtract pi over 2. When you do the -2 times the pi over 4, so the main things you guys are mixing up is that multiplication with fractions, you get to multiply straight across, and that it's addition and subtraction that you need the common denominators. So when I multiply these together, I can multiply straight across and then reduce, or I can reduce right away. So like 2 goes into 4 twice. So I would have negative pi over 2 minus pi over 2. That will give me negative 2 pi over 2, which is negative pi. And I'm going to go back through and do the next one. So now we're going to do pi over 2. And while you guys are working later and I'm stamping, I can help anyone who's really struggling with the fractions yet again work on the fractions, okay? So my next angle from here is pi over 2. I want to multiply pi over 2 times -2 and subtract pi over 2, okay? So first I focus on the multiplication. You can multiply straight across and then reduce, or you can reduce it how it is right now, like that these 2's would cancel. So this would be negative pi minus pi over 2. But I want a common denominator. Okay, remember our pi is like it has a 1 currently in the denominator, so if I want a common denominator, timesing them by 2, so I'd have negative 2 pi over 2 minus pi over 2. So that's a denominator of 2, and I have negative 2 pi minus 1 pi, so that's going to make negative 3 pi. All right, so then we're going to do the same thing with 3 pi over 4. And take that one and plug it back in. So I'm going to do -2 times 3 pi over 4 and subtract pi over 2. Start focusing on your multiplication first so that 2 and that 4 can reduce. So that multiplication answer is -3 pi over 2. I'm subtracting pi over 2. So that's a denominator of 2. And in the numerator, -3 pi minus 1 pi would be -4 pi. And that reduces to be -2 pi. Okay? And then we'll do the last one, which is pi. So I'm going to do -2 times pi minus pi over 2. So that's -2 pi minus pi over 2. Remember, just take your time and fill in the denominators. I feel like most of you, if you're still struggling with the fractions, it's just about taking time to do it correctly. So this would be -4 pi over 2 minus pi over 2. So that will give me -5 pi over 2. Okay. All right. From here on out, it's really similar to what you were doing before. You have some points. You want to scale the x-axis in the most convenient way. Okay, so we're going to try and figure out how far apart the points are for the x's to see how we want to scale it. And then we just know it's going to look a little bit different than our previous graphs, but we can still plot the points and then continue the pattern to see what it's going to look like. Okay, so for my scale for my axis, okay, if I'm not sure what to scale it by, I just take something up here and subtract the previous one from it and see how far apart they are. Okay, so let's say I just take these two and I do -pi minus -pi over 2. I'm going to make a common denominator. So that's -2 pi over 2 minus -pi over 2. So those will become like a plus. So this is going to give me -pi over 2. Now the fact that it's negative shouldn't really worry you. It's just saying we want to count by pi over 2's, but I was looking at all things on the negative side of the x-axis, so my answer ended up negative, but they are still pi over 2 apart. So I believe that I want my scale to be pi over 2. Okay? And that's what I'm going to try to do. For my y-axis, we can still scale it by ones, but I'm going to make that one really far away because look what we have to plot on the y. We have to plot 1/3. So I'm just going to make it convenient to plot 1/3. You can just label things 1/3 on the y-axis if you want to as well. Okay. So on our graph, we're going to start by giving ourselves some points for the axis. So we said I wanted to count by pi over 2's. So remember, you're just going 1 pi over 2, 2 pi over 2, 3 pi over 2, okay? And then reducing what's there. And then the negatives would go on the other side, but as they move away from 0, they should move away from 0 in the same order. So the first mark over here should be -pi over 2, -pi, -3 pi over 2, -2 pi, -5 pi over 2, -3 pi. Okay. And then I'm going to make one just like really far up here so my 1/3 is like easy to plot. Okay. Is this okay with everybody? All right, so we're going to plot the points. I'm going to plot the points in one color, kind of like when I came around the answer to the warm-up and like highlighted it. I'm going to plot the points from my table in one color and then see if I can continue them. I'm just doing it in different colors here so that you guys can see the difference. So the points from the table, I'll zoom back in a second. I had -pi over 2, 0, -pi 1/3, -3 pi over 2 was undefined, -2 pi -1/3, -5 pi over 2, 0. So here's what I have on the graph. Now keep in mind, do you know what this is supposed to look like, right? Okay. Biggest mistake people make right here, they just put an asymptote at the next mark right here and an asymptote at the next mark right here, and they fill in these curves, but then they're missing one point, right? There's really 3 points that we're graphing between the asymptotes. We're graphing a point above the middle, We're graphing the point that's at the middle, but then we should also be graphing a point that is below that, okay? So if I extend this pattern, think about this now as being this starting point. After it hit that point, it went down, and then there was an asymptote. So if I continued from here, this next point should go down, and then there would be an asymptote. Okay? From the other side, if this point is like this one, and this point is like this one, then there should be a third point in there that's slightly above after that, so that would be here, and then the next asymptote. Okay? And that helps me see a little bit better now the way my curves would be filled in. Okay? And we've been asking you guys to graph 2 periods. This is 2 periods. You could continue this pattern and graph more than 2 periods if you wanted. Okay? Remember that you guys really worked with 5 points in the parent function, which means if you're going to call this 1 period of the graph, you should have your 2 asymptotes, and then there should be 3 other points that you're graphing there so that you don't accidentally put something where it doesn't go. Okay? All right, and then the last thing you have to do is list those characteristics that we've been listing. So what did we say about tangent? When you see this list, what's the thing you should immediately know just because you're graphing a tangent? You could fill it in right away. Amplitude should be none. What did we say phase shift was? For those of you that were struggling, I talked with you yesterday. Phase shift is just another way to say what? Horizontal shifting. So just look up at your chart or what you wrote up here. We said we're shifting to the left pi over 2. Literally just write that for your phase shift. Frequency is something that I should know once I know the period, and period I have to figure out a little bit, okay? So what's normally the period for a tangent function when we looked at the parent? Pi. What adjusts the length of the period? What kind of transformation? What's that? I didn't hear you, sorry. Okay, good. The B value is what's affecting it, whether it was horizontally stretched or compressed. So this graph was horizontally stretched, right? The x's were times by 2. Okay, we see that there. That's exactly what we want to happen with our period. So then we get 2 pi. Okay, and then I should automatically know the frequency. Then I would consider the frequency to be 1 over 2 pi, the reciprocal of that. Okay.